So carrying over with today, we're going to talk about integrating functional safety standards, ASPICE and cybersecurity. Nikhil's going to give you a 30-minute talk on that. So with the expectations over 113, 126, and what was that? How many was that number? 400 and something work products?
It's part of the slide.
It's part of the slide. Okay, there's a lot of work products there that we have to do across the spectrum when we are launching a new product or doing new product development. And so to integrate that with Automotive SPICE and to integrate that with 21434, we do have a lot of redundant activities in terms of new product development and creation. We also have to we have to comply with our legal and regulatory requirements and any of those standalone processes that might be given to us internally or by our customers as well too. So Omnex has pioneered and is helping our automotive customers and our tier 2s to evolve in electric and autonomous vehicle development. Let me just move on to Nikhil's bio. So Nikhil's been a senior consultant now, right? Pretty much.
You can say project manager.
He is a project manager. That is your official title. That is absolutely correct. Nikhil's been around for quite a while, looking at design and development of hardware, software, and mechanical systems and components. I know Nikhil leads a lot of use of our FMEA software for EV and AV development, which he's quite well praised for. That much I know. It says, in terms of standards such as Automotive SPICE 26262, functional safety, ISO 9001, and IATF for quality management system, Nikhil has been involved with performing detailed documentation reviews, Automotive SPICE and functional safety and QMS assessments. Also with the development of documentation and conducting rollouts. Nikhil is a certified green belt in Lean Six Sigma methodologies and a certified quality process analyst. He is an exemplar global certified lead auditor for IATF 16949. Nikhil, welcome. Welcome. We look forward to hearing you.
Okay, so before I dive into the topic, just want to have a quick show of hands because there's been so many terms that's been thrown around in the day, so many acronyms, terms, ASPICE, functional safety. So with just a simple show of hands, can you tell me how many of you know ASPICE at this point? Okay, all right. Okay, that's not bad. All right. And then functional safety, let's say. Okay, we got good. All right. And lastly, cybersecurity. Okay, all right. So I'd average about 40% of the room. So there's still some potential for some people to be exploring these new terms. And that is also my trick of getting you all to lift your hands and throw away your sleeping sensation after the wonderful meal we had. I know Anthony already tried that once, but all right. So I'll get right into the topic. So what are we going to be covering in this presentation? Since Marty already went through my bio, I'm just going to skip that. Just two key pointers on the specific topic. So in ASPICE, I'm a principal assessor. In functional safety, again, I'm a certified functional safety implementer. So I work with our teams to help implement functional safety practices for a lot of our customers. And same with cybersecurity as well. So let me get you into the topic. So we're going to, again, talk about what these terms are specifically when we're saying ASPICE, functional safety, cybersecurity. Very brief, I know, because we've been talking about it on and on, so I won't dive too much into it. And we'll look at the problem statement, solution, summary, and then we'll dive into a panel discussion with some of these key people here who are with us today. So, so please reserve the questions towards the end. And there are papers that are already on your tables. So please note your questions down so that when we get to the panel discussions, I think we can leverage those questions, okay? So what is Automotive SPICE? Ranjit Chabra, who's joining us here. So he's going to be diving a lot more deeper into ASPICE specifically later this afternoon. But specifically, the key takeaway that I want you all to have from this slide is ASPICE is meant to help you with the main term everybody has. I got an ASPICE assessment. But keep in mind, it's not just an ASPICE assessment. You ought to use ASPICE to help implement your embedded systems development into your organization. So that's a tool that you can use to implement the software development processes and also systems, in other words, in your organization. So you have to use it to implement, only then you can get to assessment. But everybody says, oh, I got an ASPICE assessment. That's the most common thing we hear, right? But so that's something key. So it helps you to have better quality products coming out from ASPICE. If you have ASPICE in the project, means you have better quality products coming out of it, lesser defects, more efficient processes. So that's the whole objective. Now, moving on to functional safety, I know Brian's here with us, and he went, with that topic this morning, great presentation. So he already explained it pretty well. So functional safety, you're talking about, if I have a mechanical rod that's going into a car, that's not functional safety, right? We're talking about electronic and electric systems. So you've got to have some hardware and some software in it typically for functional safety to be having. Think about your airbag. Think about the lane keeping assist, the LiDAR system, the sensors, everything that has to do with something that has some electronics into it. And lastly, cybersecurity. So why is cybersecurity being brought up? Again, V2V and V2 everything. What does that mean? V2V is vehicle to vehicle. But nowadays, we got vehicle communicating to everything else, right? The cloud. You got soon, I'm pretty sure, maybe in the highways, someday we're going to get to level 4 and level 5 autonomous driving. And what are we going to do in the car? Everybody wants to watch some Netflix, or maybe they want to work, or they want to, just do something, right? There's a lot of scope for all of that. There's a lot of industries working on that. So you got to provide connectivity there. And maybe if you got like Starlink, for example, that's connecting directly to the satellite, then that's another thing, right? So there are so many, in cybersecurity, they call it attack vectors, right? So these are pathways that can be leveraged by people who want to cause malicious, they want to cause some cybersecurity issues, let's say. So they want to hack into your car. So these are pathways that they can all leverage. So that's why these three topics are important. And in the panel discussion, we'll talk about many other standards also. But to get it started, we'll focus on these three. And like I said, why all of this matters? With all of these products that are coming out, you're seeing how cars are getting even more and more complex, right? Poor quality embedded systems that are not reliable and they fail. Like you don't want to have that breaking down on the highway. And then systems that can be easily hacked into, causing unreliable consequences. You're going 90 miles per hour. Maybe that's over the speed limit. Maybe you shouldn't. But you're going on the highway and the airbag deploys. What do, right? You don't want that happening, right? And again, a lot of systems being developed as cool features in cars, but not necessarily, you're not thinking about the end impact. Is there a potential for this to have some safety-related consequence? It's a nice feature to have, but we got to think deeper into that. And lastly, also, we won't dive too much into sort of, but what about scenarios of misuse, right? I got a picture right up at the right top corner, like we talked about Netflix. Like you shouldn't be watching these things while you're driving the car, but what if you could program some, that big LCD screen that you see in all of these cars and have broadcasted content? That can cause driver distraction and, of course, highway pileups. So you got that down. So now the problem statement. So this is a diagram that has come up in previous presentations too, but what is it? It's the ASPICE process framework. So, and you see here in the ASPICE, you got, there are about 32 blocks if you count all of them, okay? If you add up all the 32, and they call 16 out of those to be significant ones as BDA scope. So you got ASPICE there. And then on the right-hand side, you got functional safety. And then lastly, I'm just gonna bring up cybersecurity. So when organizations implement these standards, what do? They end up implementing each of these blocks as separate processes. So what? You got 32 plus 50 plus something else. So everything is like separate. Like you got so many processes, so many different ways of doing the same thing. If you're talking about systems design, there's 10 different ways of doing systems design. It just makes things complicated. So Same thing with work products. So with work products, we're talking about artifacts coming out from your processes. So you're all familiar with SIPOC model, right? You have inputs, you have a process, something's coming out, that's your output. In ASPICE, they call it what? They call it as work products, also called as artifacts. In ISO 9000, you could call it like records. These are records being generated by the processes. So I know Marty had a question earlier. What's the total number here? Okay, I'll make it easy. It's just 434 if you count it all, okay? So 434 records, if you're going to be creating one single record for each one of these processes, that's quite a lot of documents to control, right? So why is this a problem? You're talking about redundant activities, right? So you have processes that are doing the same thing 2-3 different ways. And also we're talking about loss of productive development time that is being spent into generating non-value added artifacts. So I have one record, I have a checklist that shows how I reviewed my systems requirements from an ASPICE point of view. I have another one from a functional safety point of view, a third checklist, again, from the point of view of cybersecurity. So you're talking about wasted time and effort, right? So also something to keep in mind is tailoring, which is a little bit more later when we get into how to implement these systems. We don't necessarily have to have cybersecurity for everything or functional safety for everything. If you're designing some system that may not have safety impact or cybersecurity, what they call as relevance, right? But the point is, you should be having a system to tailor these things into different ways. So redundant metrics again. So maybe one department reporting information a certain way and another department reporting the same information in a different way. You have people spending time together, pulling data. Somebody mentioned Jira, right? You got to download information, put into an Excel, run a chart, have a macro do that for you. It's all wasted time. And then you have redundant reviews. So redundant reviews, like I said, you have in functional safety, they call it confirmation measures, and part of which is confirmation review. So you have, again, a lot of that happening. Now, audits and assessments, that's another one. So you got a program that has compliance needs for, let's say, a level 2 ASPICE requirement. And second one for functional safety of, let's say, ASIL B or C. And then also there's some requirements on cybersecurity. So now you have to do 3 different types of audits and assessments. There's like a whole lot of wasted time there. So how can we make these things better, right? And lastly here, different sets of requirements to suppliers. So you do the develop, let's say you are doing the systems development and also part of the software development, and you also have your supply contributing a portion of the software development or maybe the hardware development. Now, how do you communicate your requirements if you don't have a central way of doing it? Like I'm going to have one department from my organization communicate the set of requirements to my supplier one way, another engineer communicating a different set of requirements. So the guy getting at the supplier, he's like, oh, I got these 3-4 different documents. What am I supposed to do? And maybe you even have contradicting requirements between them. So these are things to, so how can we streamline this, right? So that's the key thing there. Also, all of this adds up as cost to company, right? So we are talking about wasted time and effort, and then also employee perception. I spend 80% of my time doing non-value added activities, 20% of my time if I get that to do effective stuff, right? So that's another one. And then that means you don't have enough time to actually do the job that you're meant to do. So how do you innovate? So these are, again, the challenges, right? So we covered the problem statement. Now let's talk about the solution. So I think I already gave you the solution right up at the start when I showed you the title of the presentation. It's about integration, right? If you didn't get that, then it's a challenge, but you get the point. So what we're trying to do is integration. So when we talk about integration, we are talking about integration in 2 different ways. And I want to leverage what in the FAW presentation that we had from Ms. Yang, she mentioned in sort of example, she used how there's the sort of process integration, and there's also the sort of work product integration she mentioned, right? So that's the two different aspects. We have the processes that should be integrated. That's one point. Then you have the work products that should be integrated as well, because you can't generate integrated work products without integrated processes. That's the key thing, right? So most of you, I'd say, I know we did a poll earlier. Maybe we had about 40% of you that you knew ASPICE, functional safety, and cybersecurity, but there was the 60% who didn't. But you all probably know 9001, and you're all familiar with they call it the process map that goes from the customer to the customer, right? That's what we have here. And this is just an example. Again, you have to fit it to the different organizations depending upon the context. But you have inputs coming from the customer that should be run through the processes of the organization, and you have the output going again to the customer. That's your end deliverables. So instead of having, like, for example, on this view, as a simple example, if we're talking about configuration management, we don't have one configuration management for ASPICE versus cybersecurity or functional safety. It's just a configuration management process that's affecting your product. What are you delivering to the customer, right? So each of these processes, there's no two ways of doing it. It's just one way. Same thing with work products. So, Chad has covered this also multiple times. And I think Omnex has been at the forefront advocating for this since maybe a couple of decades now, I guess. So we talked about the 434 work products. So if you put it all together, and I'll show you some statistics also to support this in the upcoming slides, we could get up to about 200 integrated work products. That's about like 50% less, okay? And what does that mean? That means through digitalization that Anthony just covered in the previous presentation, where if you have like a single framework, or let's say a platform where you can have all of these different work products coming together, it translates down to savings and revenue for the company. So this is again a statistics from an Omnex study that we did for a battery pack program, where we had a system of battery management systems, some hardware and software, with about 100 engineers for 2-year product development. There was about 1.56 million savings per program in net present value. Okay, so that's the key takeaway there. It saves time and money. So now this is again how did we base off some of that numbers, giving you some statistics there. So we took functional safety as the base, and I'll tell you why. ASPICE would have been usually the contender, but if you look at ASPICE, you don't really have much impact on manufacturing. It's mainly to do with systems and software development and your supporting processes. But if you look at functional safety, you have manufacturing also coming into picture. That's the reason why we took functional safety as the base. So there's about, on the left-hand side, if you look at IATF and food functional safety integration, there's about 42%. And then you have ASPICE functional safety, 78% integration. And then you have cybersecurity, there's about 60% integration. And then lastly, SOTIF and functional safety, which is about 52%. So again, we're talking about work product integration here. And how do we do this, or how can we, realize this at the end? So this should start all the way from your initial feasibility check. Let's say you have a new program coming to your organization, and you have the sales team, technical sales team that is taking a look at the RFQ. They're going through the requirements. They see a line called ASIL-C. Okay, they say, oh, that's not bad. Okay, we check the sign, box. We move on to the next line. Well, you should probably get somebody from functional safety to take a look at the next set of requirements. So these are some of the basic things we should start doing, right? And also, same thing to do with cybersecurity or any of the other things for that matter. So there's better education that should be done so that people in each process know what they should be looking out for. Second bullet point, leveraging the engineering V model. So again, if you look at all of these standards that we saw in the earlier slides, all of them have V model as common. So it's something you can definitely see the overlap between all of those. And then Some of these have concept phase. So if you look at especially functional safety and cybersecurity, there's the integrated concept phase. And then also you could bring it back into your typical APQP process that has the 5-phase APQP, and some organizations have a 6-phase APQP, whichever that is. So you could integrate these back into your organization's APQP phases. And again, in an earlier presentation, it was mentioned we don't have different requirements, right? Requirements are so important. It's what is the requirements for my product? Brian emphasized this pretty well also. So if I have requirements, I need to again have traceability all the way back to stakeholder through my systems development, software, hardware development, all of those. So we just need to have that as, again, as an integrated set of requirements. And then also different levels of testing, unit integration, qualification. Those can be again harmonized. You talked about configuration management. I have product configuration. And then also when we talk about special characteristics is something most of you are familiar with, right? We have special characteristics, but what about safety characteristics? What about cybersecurity characteristics? Like cybersecurity characteristics, like if you're putting your product and manufacturing it, or let's say, is there a way there's a port somebody can easily access and plug in something and gain access into the vehicle? You know, things to be thought about, right? So that could be a special characteristic. Or yeah, so when you look at the next one, we're talking about integrated audits, assessments, and reviews. We already talked about that. And then also the last point about suppliers, we're talking about doing development interface agreement, cybersecurity interface agreement. It's just like a set of requirements that you're doing with the supplier, what the supplier should do versus what you should be doing. So that it's very clear these parts of the standard are going to be satisfied by the supplier versus these are going to be satisfied by my organization. So to put this into perspective, I think this arrow has come up in quite a few presentations today. It's a popular one I see. So, but with a different chart on top of it. So in the previous one, I showed you how work products can be integrated. All I'm saying here is when you do the process integration, where should you be typically starting? At Omnex, what we've advised is when you start with an integrated implementation, you should start with integrated IATF, ASPICE, and functional safety. And then build on top of that cybersecurity, and then you could even get to SOTIF. And I'm pretty sure the list is not going to end. You're going to see more of it coming in the future. And I think we'll have some interesting discussions in the panel coming up. So yeah, that's the key point there. So without further ado, I'll get into the summary. So key takeaways. Integration should be focused on bringing additional requirements into an existing QMS at the organization rather than creating standalone islands of information, right? So that's one. All of this helps you save time, cost, and also helps you with productivity. Big deal. And then third one, we saw Anthony's presentation about digital workflows, how that's like the #1 aspect in all of this. So I think this bullet point here and the second last one also, all of these go together because you're getting a data, all of this is going to be in one platform. How can you use raw data to give you meaningful information at the end and make informed decisions, right? So that's what we're talking about. So integrated processes help you do that. I don't want just like how cybersecurity is doing versus functional safety might be reported in a different dashboard. Maybe it's not being looked at. We're talking about product metrics at the end. Did I fulfill functional safety? Did I fulfill cybersecurity? Did I fulfill my ASPICE capability, right? If I did one place well and the other place is not so well, then we still haven't met the objectives. And then also, last bullet point, and I conclude with this, is to, while all of this may sound like the right way to do things, but we should not over-engineer the processes and make it too complicated. We're not talking about creating 30, 40 pages of process documents, and then nobody's able to follow that through. How can we make it more understandable and readable and also implementable by the users? So And with that, I will conclude my presentation.